Getting a payload into orbit is now a standard engineering task. The more difficult question for the next decade of exploration is how a national agency chooses to operate once it leaves the atmosphere. Currently, two distinct models are seeing success. NASA relies on private commercial partners to build infrastructure, trading direct control for the ability to operate at a massive scale. In contrast, the Indian Space Research Organization, or ISRO, executes a strictly state-led strategy. They develop almost every component in-house to build foundational national sovereignty. For those allocating capital or planning careers, the dilemma is clear. Which of these structural models provides better long-term stability and a higher return on investment? To find the answer, we have to look at how these models perform across three specific domains: lunar exploration, orbital infrastructure, and innovation velocity. Understanding this structural split is the only way for professionals and investors to accurately forecast the trajectory of the global space economy. Look at how both agencies are returning to the moon. NASA's Artemis program uses its federal budget to hire private contractors for hardware development. This approach creates massive technological scale and places a diverse human element at the forefront of the lunar return. Because multiple commercial vendors are testing hardware like the Orion module simultaneously, the rate of technological iteration increases significantly. But there is a trade-off. The national agency is now highly dependent on the financial health and production timelines of private corporations. India's approach is the alternative. The Chandrayaan program is a strictly state-led human spaceflight initiative. ISRO's mandate is to develop everything in-house, ensuring the government maintains absolute ownership of all engineering data. This domestic capability is proven through hardware, like the Chandrayaan crew module, developed independently within India. ISRO's trade-off is time. Avoiding commercial partnerships often leads to slower operational timelines and delayed lunar milestones. Lunar strategy forces a choice. You can prioritize rapid deployment through corporate dependency, or secure total, though slower, national ownership. We see a similar split in low Earth orbit, which is transitioning from a scientific domain into a commercial ecosystem. NASA's strategy is to hand over ISS resupply operations to commercial entities to lower the cost per kilogram to orbit. Maintaining current orbital infrastructure at this scale requires the constant high-volume resupply that private vendors can provide. The trade-off for this approach is that orbital research becomes increasingly driven by profit incentives rather than foundational science. ISRO's counter-strategy involves a state-mandated goal to construct a dedicated, independent Indian space station. While this secures an uninterrupted national laboratory, it means the state carries the entire financial burden without commercial offsets. Sustaining a presence in orbit requires agencies to either embrace commercial market forces or shoulder the high cost of absolute independence. This divergence is driven by two different engineering philosophies: rapid reusability versus single-use perfection. The commercial space strategy focuses entirely on launching, landing, and turning around these reusable vehicles as fast as physically possible. This reusability leads to high launch frequencies and significant public visibility. Specific hardware, like these landing legs and guidance systems, is what makes this launch frequency possible. However, this requires vast private risk capital to survive the failures that occur during public testing. ISRO takes a different path, focusing on methodical, one-off scientific milestones. Under leaders like ISRO Chairman S. Somanoff, the agency follows a lean state approach that stretches limited resources. This methodical style cultivates domestic talent and leads to extremely high mission success rates on initial attempts. The trade-off is that ISRO misses the immediate economies of scale that reusable rockets currently provide. Ultimately, the innovation engine forces a choice between explosive, high-risk iteration and methodical, highly efficient state cultivation over time. We can map these two strategies based on operational speed and risk versus cost efficiency and sovereign control. ISRO prioritizes sovereignty and efficiency, but moves more slowly on operational timelines. The NASA and commercial model maximizes speed and risk tolerance while delegating direct sovereign control. Agencies no longer follow a single globally accepted blueprint for their operations. Space strategy currently follows two paths: treating orbit as an economic frontier to be optimized for profit, or securing it as critical national infrastructure. If you are looking for rapid technological leaps and want to participate in a profit-driven orbital economy, the NASA/commercial paradigm is your focus. If you value cost efficiency and foundational scientific sovereignty, the ISRO model is the benchmark to follow. India's methodical growth proves that a strictly state-led program is still a formidable global force. The sustainability of these operational models over the next decade will ultimately determine which strategy succeeds.